So in this video we're going to have a look at the concept of a convergent geometric series, the sum to infinity formula, and a use of the sum to infinity formula to solve a problem. So for a series to be convergent, what that means is that as you go along your terms, as you tend towards the nth term, that must tend towards 0 as your number of terms tend towards infinity. So the further along you go, the closer and closer your terms will get to 0 until they approach 0 as you head towards the infinite number of terms. Now what this means is that it will start to narrow towards a value and eventually it will have a limit at that value. Now, specifically for a geometric series, in order for that to be convergent, is all dependent on what the R value is, the common ratio. Now, for this to be true, the common ratio, the R value, has to be between -1 to 1, not including, but between those values. Or in modulus notation, the modulus of R is less than 1. Okay, they mean the same thing and you can use either notation. Now what this does is it modifies the sum of the first n terms, such that as long as R is between -1 and 1, that if your n goes towards infinity, your R value, your R to the n, will tend towards 0. Because if it's a number between -1 to 1, and you've got a power on there that's getting increasingly larger, your number will head towards 0, which actually means that this entire bracket here, this 1 minus R to the n, goes towards just 1. 1 minus 0 is 1. So in other words, if we have a times that, we're just left with an a in the numerator, and actually that's what the formula is for the sum to infinity. That the sum to infinity is equal to a over 1 minus R. Okay? It's a formula that you need to remember, but you can derive it from the sum of the first n terms quite simply. So let's use this formula then, and the concept of a convergent geometric series to solve this problem. So this problem says, explain why the geometric series 24 plus minus 16 plus 10 over 10 and 2/3 plus so on converges, and find its sum to infinity. So let's deal with the first bit, the explanation of why this series converges. Well, we're back to the definition of we're looking at an R value, so we need to find what our R value is. So our R value, simply we can take the second term divided by the first term, which in this case is -16 divided by 24, which simplifies to -2 over 3, -2/3. That value is key because for a geometric series to converge, the R value must be between -1 to 1, which it is, so therefore the sequence will converge, so we just need to write that as a statement. So as R is between -1 to 1, this implies the geometric series converges. Okay, it's as simple as that. So that's our first part, that's our explanation. Now we need to find its sum to infinity, so we're going to use the formula. So we have our R value, which is -2 over 3. We also need a value for A, which is the first term of our series, which is 24. So therefore our sum to infinity is equal to 24 over 1 minus -2 over 3. 1 minus -2 over 3 becomes 5 over 3, and 24 divided by 5 over 3, which is 24 times 3 over 5, which gets us 72 over 5, or as a decimal, 14.4 if you prefer. Either of those would be fine, and they're in the exact form, and that's our sum to infinity. So we've seen how we get the formula for the sum to infinity for a convergent geometric series and the conditions for that, and then use that for a simple problem.